All right, so today we are going to learn how to add and subtract rational expressions. So our goal, like I said, is to add and subtract rational expressions. A rational expression, again, is something that is basically a fraction that will have variables in it. So it's basically working with fractions. So when you add or subtract fractions, you must have a common denominator. So that's really important that you remember that you must have a common denominator when you are adding and subtracting fractions. You do not need a common denominator, however, when you're multiplying and dividing. Now, we're going to come back to these couple examples in a minute. Right now, I want to look at examples that have adding or subtracting with like denominators, where your denominators are the same, because these are the easy ones. If your denominators are already the same, then you simply have to add your numerators. So, and the denominator doesn't change. So if your denominator is 3x minus 5 here, 3x minus 5 there, and you're adding, the denominator is going to be 3x minus 5 here. Then in your numerator, take the 4x plus the 2x, because those are like terms, and add them together, and you get 6x, or not squared, 6x. Then take the negative 7 plus the 3, add those together, and you get negative 4. Now, if you can simplify this fraction, then you must do that. So let's see, can this be simplified? Well, if I'm going to simplify this, I would have to factor the numerator. If I factor this numerator, I could factor out a 2, because both 6 and 4 can be divided by 2. So I can factor out a 2. Actually, I'm going to put this below it. So put the 2 on the outside. And then if I divide both of these by 2, I'll get 3x minus 2 in parentheses. The denominator is still 3x minus 5. So had I gotten a 3x minus 5 on the top to reduce with the 3x minus 5 on the bottom, that would make this problem a little bit more interesting. But the 3x minus 2 and the 3x minus 5 are not the same thing. So we cannot do anything further. Because this could not be reduced, you didn't really need to factor that numerator. So either answer is correct. All right, the other thing we need to do is state our domain or undefined values. So once again, just like with multiplying and dividing, your denominator cannot equal 0. So what I'm going to do is off to the side to state my undefined values, take my denominator, which is the 3x minus 5, and state that it cannot equal 0. And then solve this little equation here by adding 5 and dividing by 3. So then I get my statement, x cannot equal 5/3. So if I were to put 5/3 in for x here, I would get 0 in the denominator, which is not allowed. So this is my undefined value. And this is my simplified expression. And you do need to have both in order to get 100% on each problem. Okay, the next example we have is a minus sign. We still have the same denominator, so that makes this problem a little bit easier to start with. But this one is actually going to be a little bit more interesting and a little bit more difficult. There is a problem like this on your assignment, which is why I have to do this example to help you with that. All right, so your denominator is the same, so it's going to stay the same here. There's then to subtract, just rewrite this as 14x. Just rewrite this as 14x minus 2x squared. Okay, in order to see if this can be reduced, I have to factor my numerator. In order to factor the numerator, I do need to put this in the right order. So reorder or rewrite in correct order. First, so if I look at these two terms, 14x and 2x squared, the negative 2x squared should be first because it has the higher exponent. Then put the 14x second. Since there's no sign in front of it, it's going to be a positive 14x. Now that I've put these in the correct order, factor out what they have in common. Both of them can be divided by 2. Both of them have an x. You also have a leading coefficient that's negative. So just like before, when that leading coefficient is negative, you must factor out a negative. So we're going to factor out a negative 2x. So negative 2x then would go in front. When I divide both of these terms by negative 2x, I'll get x minus 7. And that x minus 7 in the numerator now can reduce with the x minus 7 in the denominator. So not all of your problems are going to work out this way. A lot of them do not reduce at the end, but there are a few that do. So I'm going to have some examples that show that. So your examples aren't going to be exactly like your problems, but they'll be close enough. So the x minus 7 at the top reduces with the x minus 7 at the bottom. So your simplified answer then is just negative 2x. But don't forget your undefined value is whatever is going to make the denominator equal to 0. So if you have x minus 7 in the denominator, the only thing that's going to make the x minus 7 equal to 0 is if x equals 7. So x cannot equal 7. So if you have x minus 7, your undefined value is positive 7. Remember, it's always like the opposite. All right, so now we've stated our undefined value and we've stated our simplified expression. Now we're going to look at things that do not have the same denominator. So adding or subtracting with unlike denominators. Before doing that, though, I'm going to go back to these a couple examples that I had up here, and I'm going to show you how we're going to add and subtract these, and I'm going to use the methods that are similar to what you're going to have to use when you're adding and subtracting. So I know that there's other ways of doing this, but I want you to focus on the denominators. And we're going to factor the denominators. So the 4 is your numerator. 9 can factor into 3 times 3. 15, you have a 15 in the denominator. That can factor into 3 times 5. So if we look at the factors of the numerator here, and we look at the factors of the numerator here, they already have a 3 in common. But what is this first fraction missing that this one has? Well, it already has a 3, but it doesn't have a 5, which means we need to multiply this fraction times a 5 on both the top and the bottom to make them the same. Oops. 4 over 3 times 3. And then we're going to multiply the top by 5 and the bottom by 5. So now, because whatever you do to the top, you have to do to the bottom, and vice versa. So now my denominator here has a 3 times a 3 times a 5. Well, over here, this fraction has a 3 and a 5 in the denominator. So if we're trying to make this denominator the same as this denominator, it needs another 3 because it has a 3 and a 5, but this has 2 3s and a 5. So we need to multiply this fraction by another 3. So that means your least common denominator is 3 times 3 times 5, which ends up multiplying together to equal 45. So we're going to have that here in a minute. So hopefully that makes sense why your denominator is 3 times 3 times 5. All right, now what we want to do is multiply our numerators together and then add. So 4 times 5 is 20. 8 times 3 is 24. When I add those together, I get 44. My denominator is 45. If you can reduce this fraction, then reduce it. Otherwise, leave it alone. 44 over 45 cannot be reduced, so that is our final answer. All right, let's look at one more basic fraction. So we've got 5/3 minus 9 over 7. This time the denominators cannot be factored, which means the greatest common or the least common denominator is going to be 3 times 7, so which would be 21. So the first fraction, use green here, already has a denominator of 3, so we need to multiply it by 7 on the top and the bottom. Your second fraction already has a denominator of 7, so we need to multiply it by 3 on the top and the bottom. Now multiply those numerators and then subtract. So when we multiply 5 times 7, we get 35. When you multiply 9 times 3, we get 27. And then when we subtract, we get 8. Your denominator, 3 times 7, is 21. This cannot be reduced, so that's as far as we can go. Okay, so hopefully you enjoyed that last that review of basic fractions and how to add and subtract them. Now we're going to go to our algebraic expressions. So I do have some steps listed here. Step number 1 is to factor all the denominators if necessary. So if we look at this first example here, my denominators, I'm going to leave the numerator alone, but in my denominator, I've got an x squared and a 6x. Both terms have a factor of x, so I'm going to factor out an x. When I factor out an x from both of these terms, I'm going to have x plus 6 left in parentheses. So if I divide both the terms by x, I get x plus 6. Over here, I've got an x in the numerator. In the denominator, I have x squared minus 36. So there's nothing that both terms have in common. However, this is a difference of 2 squares. And a difference of 2 squares can factor into 2 binomials. Your x squared factors into x and x. The square root of 36 is 6 and 6. In order to get a negative, your signs are plus and minus. So now that our denominators are factored, we need to get a common denominator. So the least common denominator, if your denominator here has a factor of x, then your least common denominator has to have a factor of x as well. If your denominator here has a factor of x plus 6, then the least common denominator also has to have a factor of x plus 6. This denominator has an x plus 6, but it's only got one of them, and we've already got that in our least common denominator list over here. This also has an x minus 6, which means your least common denominator must also have an x minus 6. So that's your least common denominator. X plus 6, and x minus 6. So now we need our fractions to have that same denominator. So we already have the x and the x plus 6 in this fraction. So in order to make it the same as our least common denominator, we have to multiply it by x minus 6. The second fraction already has x plus 6 and x minus 6. So if we're trying to make it the same as this leading common denominator, it already has the x plus 6, the x minus 6. It's missing that extra x that's being multiplied in front. So we're going to multiply that extra x in front. Now we're going to simplify our numerators. So the 3 has to be distributed to the x and the negative 6. 3 times x is 3x. 3 times negative 6 is negative 18. Denominator is going to be x plus 6, x minus 6. In the second fraction, you're going to multiply your x times your x, which is x squared. Denominator again is x, x plus 6, x minus 6. So now, going back to the idea from before, if you're adding two things with the same denominator, the denominator stays the same. And then you would add your numerators. So the 3x minus 18 plus x squared. Now you do want to put this in the correct order. So the correct order would have the x squared first, then the 3x minus 18. And a lot of your problems do not go further than this. A lot of them, the numerator cannot be factored. However, there are a couple problems that you have to keep simplifying this a little bit further. If you look at your if you look at your numerator, hopefully you can see that this can be factored. There are two numbers that multiply together to equal 18 that subtract to equal 3. So this can be factored. So your x squared plus 3 minus 18, the x squared will factor into x and x. The two numbers that multiply together to equal 18 that subtract to equal 3 are 6 and 3. Because your 18 is negative, your signs in your binomials are going to be different, and the larger one has to be positive. So 6 is positive, 3 is negative. The denominator doesn't change, so bring that over. So now when we were, just like when we were simplifying rational expressions the other day, if you have a common factor in the numerator and denominator, that can be reduced. But before we reduce, I'm going to state my undefined values. I always recommend that before you cross anything out, state your undefined values. All right, so you have a factor of x. The only thing that's going to make that factor of x equal to 0 is 0 itself. So x cannot equal 0. Then you have a factor of x plus 6. The only value of x that's going to make x plus 6 equal to 0 is negative 6. So x cannot equal negative 6. If you have a factor of x minus 6, then x cannot equal positive 6. So those are your undefined values. Now I'm going to simplify my fraction by reducing the x plus 6, which gives me x minus 3 in the numerator and x times x minus 6 in the denominator. And there you have it. That is your simplified fraction. These are your undefined values. All right, next example. We're going to start out the same way. We're going to factor those denominators. So a lot of factoring involved in these problems. Do not factor your numerators. The numerators stay the same. So in your denominator, you've got x squared minus x minus 20. We're going to factor that into two binomials. The x squared factors into x and x. Two numbers that multiply together to equal 20 and subtract to equal 1 are 5 and 4. Because your 20 is negative, the signs in the binomials have to be different. The larger one has to be negative to get that negative 1. So a negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. All right, then we got a minus 2x over, again, let's factor that denominator. X squared factors into x and x. Two numbers that multiply together to equal 12 that add up to 7, 3, and 4. Because your 12 is positive, your signs are going to be the same in the binomials, and they're both going to be plus, so that you get a positive 7 when you add them together and a positive 12 when you multiply them together. All right, the next thing I want to talk about is subtraction. Subtraction is the same as adding the opposite. So one thing that I recommend is that when you're subtracting, change this to a plus and put the minus in front of this term so that you don't forget to distribute the negative in the next step. All right, least common denominator. So over here you have a factor of x minus 5. So your least common denominator has to have a factor of x minus 5. You've also got a factor of x plus 4. which means your least common denominator has to have a factor of x plus 4. Over in the other fraction, you have a factor of x plus 3. So your least common denominator has to have a factor of x plus 3. You also have a factor of x plus 4, which is already in our list, so we do not need another one. So now we're trying to get our denominator to have all three of these factors. So 4x has a denominator of x minus 5 and x plus 4 already. So we need to multiply it by what's missing. Well, if you've already got x minus 5 and x plus 4, the thing you're missing is an x plus 3. So multiply by x plus 3 on the top and the bottom. The second fraction already has a factor of x plus 3 and x plus 4. So if you look at your least common denominator, what's missing is the x minus 5. So I'm going to multiply the top and the bottom by x minus 5. All right, so now we have to simplify our numerators. So distribute the 4x to the x plus 3. Distribute the negative 2x to the x minus 5. So 4x times x is 4x squared. 4x times 3 is positive 12x. The denominator has not changed. Now distribute the negative 2x to the x and the minus 5. So negative 2x times x is negative 2x squared. Negative 2x times negative 5 is a positive 10x. Denominator does not change. All right, do we now have the same denominator? Yes, we do. It might not be in the same order, but they are the same three factors. So once you have that common denominator, add your numerators. So we've got a 4x squared and a minus 2x squared. So when I combine those, I get 2x squared. I've got a positive 12x and a positive 10x. When I put those together, I get a positive 22x. My denominator will be the same, but I only need one of them now. Again, it doesn't matter what order you put these in, as long as you have an x plus 3, an x plus 5, and an x minus 4, x plus 4 and x minus 5. So this is our simplified answer. Let's state our undefined values. So if you have a factor of x plus 3, then x cannot equal negative 3. If you have a factor of x plus 4, then x cannot equal negative 4. If you have a factor of x minus 5, then x cannot equal positive 5. So now we have our undefined values and our simplified answer. Next example. All right, so in this example, the 5x minus 3 in the denominator cannot be factored. So it's going to stay the same. Let me change colors. The denominator in the second fraction can be factored. It is actually a difference of two squares. So your 5x, the 25x squared minus 9 can be factored into two binomials. The square root of 25x squared is 5x and 5x. The square root of 9 is 3 and 3. Because it's a negative, your signs are plus and minus. All right, so if we look at the two fractions, they both have the 5x minus 3. But this first fraction is missing the 5x plus 3. So we only have to multiply the first fraction by 5x plus 3 to make these fractions now have the same denominator. So now you're going to simplify your numerator by distributing the 5 to the 5x and the 3. So 5 times 5x is 25x. 5 times 3 is 15. My denominator, 5x minus 3, 5x plus 3. Then I'm going to Actually, just bring the minus 2x. So they already have the same denominator. So we distribute and bring that minus 2x along. Now combine your like terms. 25x minus 2x is 23x plus 15 in the numerator, and then 5x minus 3, 5x plus 3 in the denominator. All right, this is long. So now your denominators have to give, you have to get your undefined values from your denominators. So let me do that off to the side. So if you have a factor of 5x minus 3, then 5x minus 3 cannot equal 0. If I add 3 and then divide by 5, I get the statement x cannot equal 3/5. My other factor is 5x plus 3. So 5x plus 3 cannot equal 0. So if I subtract 3 and then divide by 5, I get the expression x cannot equal negative 3/5. So these are my undefined values. They're also called restricted values. So if you see in the directions the statement, what are the restricted values, that's the same as undefined values. And this is your simplified expression. All right, last but not least. So on some of your handouts, you're going to see the word triangle. Some of your handouts have been changed to rectangle. It's supposed to be rectangle. I've changed this problem. So if it's not already changed, change the word triangle to rectangle, and then eliminate side C. So this is what the problem should look like. So find the perimeter of a rectangle with the following sides. Side A is 8 over x minus 6. Side B is 4 over x plus 9. A good strategy to start with is to draw yourself a rectangle that has a side of 8 over x minus 6 and a side of 4 over x plus 9. Well, if this is a rectangle, then the opposite sides are the same. So if this side is 8 over x minus 6, then this side on the bottom has to also be 8 over x minus 6. If the left side is 4 over x plus 9, then the right side also has to be 4 over x plus 9. Now let's look at what we're trying to find. We're trying to find the perimeter. Well, the perimeter of things means that you add all of the sides together. Well, since the opposite sides have the same denominator, it would make sense to add the opposite sides together first. So I'm going to add the 8 over x minus 6 with the other 8 over x minus 6. Then I'm going to add the 4 over x plus 9 with the other 4 over x plus 9. When you have a common denominator, you just add the numerators. So 8 plus 8 is 16. My denominator stays the same. Over here, I have a common denominator, so simply add the numerators. 4 plus 4 is 8. X plus 9 is your denominator. All right, so now we have to combine these two fractions. Well, they do not have the same denominator, so we have to get the denominators to be the same. So if this denominator has a factor of x minus 6, we need to multiply it by the other denominator, x plus 9. If this denominator already has x plus 9, then we need to multiply it by the other denominator, x minus 6. Once again, you're going to distribute the 16 to both the x and the 9. Distribute the 8 to both the x and the minus 6. So 16 times x is 16x. 16 times 9 is 144. 8 times x is 8x. 8 times negative 6 is negative 48. Now that they have the same denominator, when you're adding, you simply add those numerators. So add your like terms, your 16x and your 8x added together is 24x. Your 144 minus 48 is a positive 96. Again, your denominator is x plus 9, x minus 6. This cannot be factored, so we're going to leave it alone. Now, the one thing with this problem you do not have to do is write your undefined values. So if it does not ask you for your undefined values, you don't need to give them. So that concludes our notes for today. Hopefully you've enjoyed that. And go ahead and start working on your Math Excel assignment that goes along with this. We will also have time tomorrow in class to work on it.